Hello, welcome back to Joint Warfighting Track. Our next presentation is from Robert Bach, and we will hear from our DEX Systems. Take it away, Robert.
Thank you very much, Marika. So I own DEX Systems, and I'm going to talk to you about all of our work, or as much as work I could fit into 20 minutes, and try to summarize at the end some of the tools that we're using and how we're offering them to the community as at large. So next slide. We were established back in 2014. We're an AI and robotics company, and we also develop advanced sensor solutions and we work for both the government and commercial customers. Now, we have two divisions. One is a military and defense division, and another division that's robotics and industrial automation division. The military and defense division has two branches, which I'll talk about on the next slides. Our core competencies, as I mentioned, are artificial intelligence and machine learning, so AI and ML. We do quite a bit of EW and SIGINT work. I'll talk a little bit about that today. We provide algorithms for advanced sensor systems, radar, EO/IR, high performance embedded computing, wireless comms, and autonomous systems. And there's our building. We bought a building last year. It's about a 10,000 square foot building in Woodstock, Georgia. So, as I mentioned, the military and defense division has two branches. One is the AI and image exploitation branch. And basically, it's just a fancy way of saying this is our imagery side of the company. AI, ATR, we do a lot of work in SAR and ISAR and EO/IR for ground, air, and satellite-based platforms. We kind of started out developing AI and ML in the presence of adversarial countermeasures. So I'll talk a little bit more about that today. And then we've expanded beyond just making robust AI, ML in presence of countermeasures, and expand to a large quality assurance toolkit for AI and ML to provide confidence in AI ML results and improve performance. I'm sorry, here we go. The other branch is a signal processing and cognitive technologies branch, which is somewhat similar to our other branch, except we're focusing more on signals like radar and RF and comms. Traditional cognitive radar applications, innovative waveform technologies, EW and SIGINT, and we're working a lot in modular open systems architecture, embedded solutions. We're working with Mercury, for example. They have a really nice platform for solving the vendor lock problem and providing hardware agnostic approaches for EW, SIGINT, and SDR applications. So this side of the company, the signal side, is a little, as you can imagine, we do quite a bit. There's a lot of focus on the implementation of AI and ML and our innovative technologies. Whereas, of course, the imagery side of the company focuses on implementation, but the implementation is quite different when you're in the imagery and not on the signal side of things. Now, we also have a robotics industrial automation division. I won't talk about that too much today. We do a lot of custom robotics, pick and place, palletizing, machine vision inspection. We do a lot of work with corrugate insertion and manipulation and some mobile robotics. We're a FANUC authorized system integrator, and we in fact have a product that's growing, and we call it the RDX series for lack of a better name. It's a family of fully autonomous bin picking solutions. So it uses AI and 3D vision to solve a really hard e-commerce problem, and we're doing quite a bit of work in that. Here's a list of and I'm not going to go through all these. I just wanted you to see that we have quite a bit going on at DEX. The imagery branch is on the left, the signals branch is on the right, and most of these are SBIR projects. Some are not SBIR, but most of them SBIR, and most of them are either active or pending, and a few of these have recently closed. But we have quite a bit going on here. I'll talk about these in more detail today, but I want to highlights here. We won the AF weapons pitch last year. We're applying again this year. We won the Army Waveform Challenge last year, and with Raytheon, that Army Astra competition, we were one of the winners there as well. Raytheon's the lead there. So I'll talk about some of these projects and try to give you an overview of what they are rather than going into details for every single one for you today. We're working quite a bit with Raytheon, and I did want to bring that up today if it was of interest to the folks on the other side. And by the way, I wasn't sure who I'm speaking to today, so I'm just trying to be kind of general and telling you what we're doing. Now, the little graphic on the bottom maybe oversimplifies us, but we develop innovative AI and ML technologies. Raytheon has tremendous synthetic data generation capabilities, and the two of us together are combining to provide improved AI ML at battlefield relevant speeds. Now, the one I do want to point out here is that second bullet, that edge, it's called EdgePED, Edge Processing Exploitation Dissemination System. This is Raytheon's project that we're a sub to. It's really a fascinating project. They're developing an ATR factory. In other words, if at the edge in the battlefield you see gaps in your ATR, you can process synthetic data at the edge, train networks, and go ahead and address new targets, new situations, new environments at the edge. So it's an exciting project to be part of. We are, of course, focused on the AI ML side of things there, supporting that part of it. And then they're developing the entire system, as well as, of course, focusing on, as I mentioned earlier, the synthetic generation capabilities. Now, the two on the bottom there, the pending projects, are somewhat similar. We are working with them. We have strong capabilities in I'll talk about it more, in QA tools for AI and ML. Figuring out how to fill in the gaps of training using synthetic data. So they provide the synthetic data, and we provide the tools for filling those gaps. And the idea is you want to address the bottlenecks in AI and ML. As you know, especially with new targets in the field, you don't have a lot of training data. So those are the types of things we're focused on. Now, the first of the directive phase 2s that's pending, we're going to be doing a lot of work in SAR on that one. The next one that's pending, we'll be doing a lot of work in RF for proximity sensors and RF fuses. But the technology is sensor agnostic for the most part. I'm going to go to the next slide here. Now, what I want to talk about today is I want to talk about our projects, but also put it in the context of the bigger problems that we're solving. Because what we're finding is our customers don't just want to know, do you have a better classifier? Can you classify this target or do X, Y, or Z? They want to know why it's working, right? And we want to know why it's working and where it's not working. So we're really focused on the why of AI and ML and looking under the hood. And those of you in this space know that AI is a black box and it's very difficult to test properly. Often you don't know why a model works, and often you don't have training data that is equal to the production data. So we're addressing these types of problems, and we're developing tools for ourselves and also developing tools for our customers, and at the end I'll talk about a product offering that we're going to provide as well. So here's the quality assurance tools that we've developed on a number of projects. So those lists of projects you've seen before, and some of this has been developed internally as well. Statistical analysis tools are really kind of the first general feature, examining the relationship between classes of data. And the idea is we want to use far less data than training to see if you can anticipate production challenges that you're going to have. So we use these statistical analysis tools to inform our pre-processing decisions in order to improve performance of our AI and ML networks. Now, we provide these to our customers if they want to use them. We have some partners. In fact, we have someone tomorrow we're briefing on it and throwing those over the fence to see if they can use it on their project. So we find these, when we find something useful, we share with other folks, see if they can find it useful, and see if we can build relationships and programs together. The other tool that we've developed, a suite of tools, are these model insight tools. So the ways to visualize representations and the transformations that a network applies to a data set. And that empowers us, when I say users, we use them, but as well as other folks, to better understand the layers of a network and how the network affects the relationship between the data points. So again, these are tools that we use, and they're expanding every day. And then the other suite of tools, this is kind of where we started in this space years ago, was robustness to adversarial attacks. Now, we talk about adversarial attack, we talk about both gradient-based and physical attacks, artifacts. And we've developed algorithms and pre-processing techniques to remove and detect and remove adversarial attacks. I'm going to go to the next slide because I see I need to move faster. Here's a project we have with the Navy, very focused on adversarial attacks, AI and ML. We developed a whole suite of technologies there to improve confidence in AI. This actually recently ended, this project. We identified weaknesses in networks. We strengthened networks against weaknesses. We demonstrated on airborne SAR data, and SRC was a partner on here. we collected data on that project, and we implemented in their Agile Condor as well as L3Harris's Hydra. And here's a little, there's a nice little just illustration of what we do here on that project. The adversarial input can, degrade a model. We have these tools on the bottom that will, detect. We call them an adversarial input detector, and then we use those tools for prediction correction, and then hopefully get a happy output and not a bad output. So I like that little illustration. I'm going to move on. Here's another project. Again, it's a very similar project. This is an SBR phase 2 that just ended. This was we won the Army weapons pitch last year, and the idea was to take our SAR missiles, our SAR classifiers, and apply them to the missile seeker problem. Adversaries are adopting countermeasure techniques from other domains to defeat SAR missile seekers. So we wanted to support the Air Force in developing classifiers that are robust to adversarial countermeasures. So a very, very successful project. They're helping us right now identify some matching funds. There's a TAC fee program. I'm sure I don't know if folks on the phone on the call here are aware of it. The Air Force has a TAC fee program where if we could find 1.8 million in the from a customer, the SBIR group will match 1.8. So actually it says 3.4, but it's recently changed to 1.8. So now it's 3.6 million. So we're either going to apply this year or we're going to apply next year for that. We have 3 years of eligibility. And this is one we're working with Raytheon on. Here's another project with the Strategic Capabilities Office. It's very similar to the other project. However, it's in the ISAR domain, and the targets are maritime targets. And we were one of 6 companies to go to, I'm sorry, one of 6 companies to win a phase 1, but the only one selected to go to phase 2. And this is a very interesting project where the sponsor is now interested in both midwave IR and ISAR classification, and they're coordinating our effort with other transition partners. I really got to move it because I'm going too slow. So I'm going to go to the next slide. This one is, I just want to point out that we're doing a lot of similar work in this SIGINT domain. So I talk about SAR, I talk about ISAR. This is all in the SIGINT domain, and we're implementing it on non-Vengelock CMOS compliant hardware with Mercury. This is some more detail about the QA tools we're developing that we use. We have, kind of 3 different layers here. There's a microscope where we do, look at the models themselves and the data themselves. Preventative action, what kind of tools is a first line of defense against natural bias and adversarial attacks, and then treatment tools. How do you fix them at the end? So, these are all the tools that we develop, and we instead of just developing, piecemeal tools that one person in the company uses, someone else uses, we develop in such a way that not only we can use them, but other people can use them as well. So I wanted to end the talk today and spend a little time talking about TOVI, which is our offering now. Basically, it's our recognition that the tools we develop for ourselves. So we have, for our ML ops, and our data scientists have developed tools for ML ops and for data scientists, and this really combines what we have done on the resource management side, which I'll talk about in a second, and the QA tools, which I already talked about. Okay, so this is what we use, and we're finding that our customers and other partners kind of have a significant interest in leveraging our tools, because we've done it in such a way that we're very efficient. And this is an experimental field, and we're being able to run experiments and leverage your resources is a big problem that we've solved for ourselves, and we're offering it now we're in the process of offering it as a comprehensive product. So what is TOVI? So the problem we had is that cloud compute is expensive, increases latency, and prevents privacy and security concerns. So we really can't do our work in the cloud. Now, on-premise computing is difficult to configure. It often requires dedicated staff, which can be very expensive. So we invested internally to develop our own resource manager, which I'll talk about in a second. And so the other problem is reusable, scalable solutions are needed to minimize costs and speed up the life cycle of machine learning research and development. So these are the problems that, basically problems of the industry as a whole, our partners as a whole, our collaborators, and our customers, and this is a problem we have ourselves. So got us thinking and talking to other folks, and other folks were very interested in using what we've developed. So our solution, we call it TOVI. There's a long story behind that I'll tell you if you're interested in learning more. It's basically resource management made easy. We have a simple web UI, and now we can have ad hoc clustering and intelligent job scheduling, and really just gets more out of our hardware. So in the past, we had dedicated desktops all over the place, and now we have one single server that everyone uses and leverages, and it's optimized to leverage the hardware. Now, as I mentioned earlier, we have QA tools, we have AI ML tools. So we built on top of it a suite of tools that we all use as well. To not, so it's not just the resource management side, it's also there's the, the data science side of this, right? So that's our solution. We call it TOVI. And just to give you a quick idea of the business and the market here, the distributed computing market is growing by leaps and bounds. By 2030, it's estimated to be 1 trillion. We can also provide reference. We're not just pulling these numbers out of the hat. And the AI ML market revenue by 2025 is 100 billion. The business model we have in mind for TOVI is that there's an open source community edition, which we're very close to releasing. Of course, there's the B2B side of things, right? So we have customers, very large customers that are interested in using this, and we're trying to get them to adopt it. One thing we've noticed is that they have, a lot of these companies, big and small, have research clusters, and these clusters are being overloaded and not used optimally. Now, not only you have the single individual cluster that's not used optimally, you have other clusters. So one cluster could be overwhelmed, another cluster is not being used at all. So we want to be able to enable folks to optimize clusters. But then you also have desktops and laptops that are being used. Can you optimize and use those as well and bring them into your network? Well, we do it, and we want other folks to use it. Then now the advanced plugins I talk about for platform customization, that's exactly where, the QA tools we talk about. Now, we've done this in the context of AI and ML, but isn't just an AI ML problem. So folks who are not in AML, we suspect will be interested in this, but, of course, we're focused on the AI and ML side. The components, so here's the ecosystem. The TOVI core is a conductor. That's the ad hoc clustering, the job scheduling, right? That's not AI ML specific, right? Everybody has that problem, but we're focused on the AI ML side. It's the plugins here. This is kind of a little bit more AI specific. So we have a data governor, the development platform, and the QA toolbox. The data governor is a file management, data set pre-processing, data set processing component. Development platform, that's where we develop our algorithms, track experiments, look at data, all that. That's the development platform. And the toolbox, those are the tools I talked about earlier for model validation, statistical analysis. We find extremely valuable, and that's really kind of our innovative side to one of the reasons that when we win is that we have a lot of tools that are very useful for us. I think that our customers and when we express these in proposals, that really resonates with our proposals. So this TOVI ecosystem really encompasses everything we're doing at RDEX. The difference in the way I'm presenting it here is that now we are now focused on not only using ourselves, we've developed in such a way now that we're ready to share this with other partners and customers. And here's the Conductor, which this is what I was talking about earlier. It's an intelligent resource manager to allow for GPU, CPU, and memory allocation across a network of devices. Now, here's what's key, right? I talked about, you may have a cluster that needs to be optimized as resource management. You may have multiple clusters that need to be optimized. One's not being used, one's overwhelmed, right? Why do that? We see it all the time. You may have desktops, laptops, idle stations, right? The idea is this is a problem we have, this is a problem other people have, and we're focused now on kind of expanding beyond just using it internally. Here's our roadmap. Might be a little too much detail for you, but right now Q3 is when we plan on releasing the first version of this, and then these are all different features, and we have a business plan. Potentially, TOVI might grow in such a way that it may require us to spin it off as a separate company. We do see a lot of opportunity there. And here's my contact information. Again, I'm not sure who's on the other line, on the other side of this. I'd love to meet you all. Here's I'm the CEO of DEX Systems. There's my email. It's robert.bock. That's B as in boy, O-C-K @ r-dex.com. So you contact me afterwards. Love to chat, learn a little bit more about what you're doing, whether or not anything that I talked about resonated with you today. My number there that's my cell phone number, 678-641-2380. And somehow I miraculously made it just in time of the 20 minutes. I think I have 5 seconds left.
Thank you very much, Robert, and thank you for being mindful of the time. Thank you, everyone, for coming to this session, and we will see you back here in 5 minutes for our next presentation. Thanks.
Thank you. What do I do?
That's it. We're just ending the session.
So I just close out here. Thank you very much. All right. Bye-bye.